Hello and welcome to BlastOne International instructional video in relation to repairing an airless pump leg. How do I know when I need to replace the packers in a pump? The packings are top and bottom. To understand the need to replace the packings, primarily you'll have material or paint escaping from this gland nut from the top of the pump. The gland nut itself creates pressure on the packers. What happens ultimately is the packers will wear from not only the piston travelling through the packings, but also it's indicative to the type of product you're using. Some products are more aggressive on the packings and the pump as opposed to your lighter, lower volume solids products. So say for example a product with silicate in it. So some products that you put through this pump are quite harsh or cause premature wear on the packings. Products with calcium silicate, products with macacious iron oxide, aluminium oxides, they all have a significant wear factor in relation to the longevity of the packings themselves. The other indicator is, of course, not only did I mention paint escaping from this gland nut, but also too you'll see a significant drop in pressure. So how can I ascertain what the drop of pressure is? Well, predominantly what you'll do is when you're spraying, you'll see the drop in pressure because the atomization from the tip to the surface of the material itself becomes diminished in the sense that the dry spray tends to follow the spray tip pattern. Also too, you'll have an undulating spray tip pattern. So when I say undulating, it'll come in and go out, come in and go out. That's indicative to ball wear as well, which is top and bottom, your primary ball, your secondary ball. So all of these factors are relative to wear within a pump itself. Primarily though, most of you would have experienced paint coming from the top of this gland nut. So that being the case, you can, with no pressure on the pump, increase some torque with the C-section spanner on this gland nut to try and torque it down a bit more to create a bit of squash on the packings, to reduce the bypass of product out the top of the gland nut. If you're unsuccessful in that and you've lost pressure, you can see that you have poor atomization. Ultimately, you need to replace the packings within the pump. So to give you some idea of how to do this thoroughly and correctly, what we're going to do is remove sections of this and remove the pump from the housing of the entire body itself. So primarily what we'll do is we'll make sure that there's no thinners in the suction hose, which goes into the material itself. So we've removed that. You'll have some runoff here, so it would pay to put a piece of rag or a container underneath the machine to catch that escaping solvent. So what we'll do is, as I mentioned yesterday, we have a knockdown section. So from here down to here is a knockdown. So we can use a hammer or you can use a pair of Stilsons. So on site, you'll find predominantly you just have a hammer. So we'll undo this and remove this suction hose. So you can remove the suction hose out of your way, which exposes the foot valve of the pump itself. The retainers here are 3 stem bolts with nylock nuts on them, and you have a linch pin in the top, a cover, and the collets underneath that. So ultimately what we're going to do is we'll put a support timber underneath the pump itself so that we can support it. So by putting a support under there, that'll hold the pump in position for me. Now, I know there's no pressure on the pump because I can operate the dump valve, there's no pressure, pull the trigger on the gun, no pressure, so it's safe to do so. So just to run through that again, before I do anything with this pump, I make sure there's no pressure in this chamber. So to ensure that there's no pressure in the chamber, open the dump valve, pull the trigger on the gun, no pressure. So now that I have no pressure in there, it's safe to dismantle the pump. So the first thing we need to do is take the hose off the pump itself. So by removing this nut here. Now, if there was pressure on that, that would be very, very tight to undo. So if the pump was pressurised, you wouldn't get that undone. So you can see there's some remnants of solvent there. Just ensure I catch that as best I can. And remove the whip check that we had on the hose previously. So now we've done that, we don't drop that in the dirt. Best to put another blank fitting in there, or put this up so that it can't be exposed to dirt and contaminants. So with this weeping off beautifully, what we can do is undo these retaining bolts, which are, as I said, nylock nuts. So you'll find that because they've been done up for some time, they'll have paint accumulation around the threads. You need to crack them. So remove these 3 bolts, stem bolts. What I'll do is I'll undo them with a ratchet spanner. So there's 3 of them. So you'll loosen them off like so. Now before I go any further, what I need to do is divorce from the fluid pump from the air motor. So that's joined with a clip. There's just a push-on clip like so. Slide that clip wire up the top of the piston, out of the way. Now the bell is holding the 2 collets. So I slide the bell up out of the way and open the collets. So if I undid all of these bolts, these series of bolts, it'd put too much pressure on the collets and I'd have trouble getting them undone. So by doing it this way, it's before it's got any pressure on there. So there's the 2 collets held with a piece of wire. So remember when you put them back together that if you put the wire to the top, the bell won't come over the top of them. So the wire is just to keep the 2 collets together, and the wire goes at the base of the collets. So now we've done that, we'll put the collets to one side so they don't get damaged. Now we've divorced the fluid pump from the air motor. We can now proceed to undo the bolts. So remember what I said, there'll be paint on these. If there is paint on these threads, you'll need to endeavour to clean the threads as best you can instead of winding the bolt over the paint. So now as I bring the fluid pump down, I need to put a support underneath just to hold that pump in place for me. So prior to dropping these 3 bolts, what I'll do is I need to put a support underneath the pump because I'm here on my own doing the job. So the best way to do is a timber support underneath. So this timber support does 2 jobs. One is supports it as the pump comes out, but also 2, when I put the pump leg back in, because it's quite heavy and you don't strain yourself and you don't pinch your fingers in these stem bolts, you're best to put a support underneath there and lift it back up into place. So we're using this to lift it down, we're using this to assist in its reinstall position. So continue to laboriously undo these bolts. Now that I've supported, it doesn't matter if I do one at a time, but just remember, when you reinstall it, you have to do these bolts up in series. You can't just do one bolt up because the pump will kick to one side and pinch on the stem. So continue to undo your bolts. The pump can't go anywhere and fall on me because it's supported by this piece of timber. And because they're nylock nuts, what you're looking for in the nylock nut is the nylon on the outside of the nut. If you find that the nylon has diminished to the stage where it's no longer obvious on the crimped section of the face of the nut, you need to replace the nuts as well. Primarily because the nylock nut is designed to screw up once and the nylon holds the nut in place to stop it coming undone. They utilise these instead of spring washers or star washers. So you can see the pump is starting to come down into position. So just remember in sequence, when you remove items from the pump, make sure you put them back in sequence as well. So remember, we've done the 3 nuts, the collets, and now this will be ready to come out. One thing you might find The legs on these vary. Also, it's indicative to the area you might be doing this job. It could be uneven ground and so forth. So for this particular installation, we put 2 blocks underneath the front of the pump to help assist the removal of the pump body with this piece of timber that I put in. So what I can do now is just put my leg on this to hold this, lift the support up, pull that out, and then basically the whole pump is sitting with a very little thread holding that in place. So now what I can do is I can put my hand on the pump and ensure that any pin retainers that are there are removed off these stem bolts. Normally the one you'll have is a pin retainer wire that holds the pin for this particular barrel, which I'll show you later on. So now I've got the pump sitting there ready to come out. I can tip that forward, tip it back, roll the pump forward, and there you have it. So ensure that all the escaping fluids go into a container and don't hurt the environment. So this one here, that is the collet retainer. The collet retainer, remember, held the collets in place, which is a bell. So to save you a lot of grief by putting all this back in there and then say, oh, I forgot that, what I normally do is, with this pin or clip, I'll slide this back up here and just put that pin on there. So this bell or collet retainer that I spoke about earlier, it pays to put it back on the shaft. That's the air motor shaft. Put it back on the shaft and slide the circlip or pin back in on the dolly so it stays there for you. Because what can happen is you can put the pump back into its position and then realise that you've forgotten to put the bell on the shaft, so you have to take the whole thing back off again. So there's a trap for young players. So now that we've removed the pump, we need to disassemble the whole thing. So you can put it on a bench and do it. 9 times out of 10 on site, there is no bench, no vise. So we'll show you 2 ways to do it, one in a vise and one without a vise. Okay, so now we've removed the pump from the pump body. We have here the piston exposed, and we also have the foot valve section. So all of this needs to be removed to expose the parts to be repaired or replaced. With this piston exposed, because it's hardened chrome, what you don't want to do is hit it with anything sharp, drop it in the dirt, drop it on a rock, because if you impregnate or dent that, the simple fact is that it's become null and void, then you can't use it again. You can actually try and remove the dent with a bit of wet and dry, but you've undermined the integrity of this particular item by damaging it. And you've got to remember too, this is a high pressure unit. So because it's high pressure, any dents or damage that you create on this piston is detrimental to the longevity of the pump itself and its operational procedure. So what you'll need if you're on site to perform this task is your C-section spanners for the filter and the castellated nut for the packings. You'll need 2 pairs of Stilsons. You will need a shifting wrench or adjustable wrench, a screwdriver, a large shifter, and the hammer, of course. So what we're looking to do is we need to take the torque off the piston or the packers themselves. Now you'll find that that could be tight. If it is tight, what you'll need to do is probably put a piece of tube on this to assist you in creating a better fulcrum to undo the castellated nut. So we loosen the castellated nut primarily to take the torque and the pinch off that piston. Now that we've done that, we've removed that. The other thing I suggest you do before you dismantle too much is also undo this particular filter housing. So if you apply a little bit of snap torque, it'll come undone a lot easier. So just remember, if you take this castellated nut all the way out and you undo this, you could hit the piston with this. So it's important to keep the castellated nut there to protect the piston from any damage that could be caused. So remember this knockdown section here, we grabbed a soft tool, brass. We can use a brass drift. You can use the Stilsons to undo this. They've designed it so that you can undo it with a hammer. So we'll do that. Remember what I said, righty-tighty, lefty-loosey. So we'll undo this. And that exposes that nylon sealing ring and the precious ringland that I talked about that you can damage quite easily. So if you hit that, you'll damage that. You'll have to dress it to make sure that the O-ring goes in there. I suggest you protect it and make sure it doesn't sustain any damage during the repair, because if you damage that ringland, that will render this particular cylinder inoperable, because it'll leak and cause you all sorts of grief. So remember, the foot valve is in the bottom, so that's your primary valve. So we need to get that valve out. Now, if you've had a lot of paint through this and it's done a fair bit of service, you'll find that sometimes is difficult to get out. What you have to be conscious of is that you can't use spanners or tools in there, because you could damage the threads. So ultimately what we do with our piece of timber we had for the pump, the foot valve itself needs to come out. Now there's 3 spaces in there, and they're in there for a reason, which will become obvious. So by hitting it on a piece of timber, I haven't damaged the face of that. That exposes a tungsten carbide seat. Now cleverly, now what they do is they'll manufacture these with 2 seats, 1, 2. So the seating ring in the tungsten carbide seat is for this ball bearing. So the ball bearing seats in that tungsten carbide seat. 316 ball, tungsten carbide seat. Sacrificial, non-sacrificial. So what you're looking for in these seats is there's a taper on the seat, a cut that goes back at a 45-degree angle. So what you're looking for, any damage in that seat. And if it's concentric and the taper's not damaged, it's still a good seat either way. So very clever technology. 316 ball, the cage that holds the ball in place. So all that does is stop the ball from travelling all the way up the barrel. And this is a standard kit. You can get a pressure loading kit which has a spring in it that holds the ball on the seat for higher volume solid products. There's 3 spaces here, or shims. These are designed, and you'll find if there's a lot of paint around them, they're a little bit difficult to separate. So you'll need to give them a good wash. But the 3 O-rings and seals, or shims, separate eventually. And these actually do 2 jobs. One is they ensure that there's sufficient pressure on the top of this to hold the seat down in place. But when we undid this, it was pointing out the front of the pump. If I forgot to put one of those shims in and it reassembled the pump, this suction pickup section would be pointing opposing, so it could be 3 o'clock instead of being at 6 o'clock. So the 3 shims are essential to ensure that the pump points and faces the right way. So the 3 shims sit on the top of that cage, not underneath. If you set them underneath, it'll give the ball more travel. So if you have a high volume solid product, it'll cause cavitation. Cavitation means that the ball doesn't sit on the seat properly and hovers over the seat, due primarily to the viscosity of the material that you're trying to pump. So the 3 shims, not on the bottom, not anywhere else, but on top, and make your suction section of the pump on your primary foot valve point at 6 o'clock, which is towards you. So what else are we looking for here? This is just a housing, nothing else, just a housing. So all we have to make sure is that it's clean, and I suggest you start reassembly after it's been cleaned. Everything's smeared with Vaseline. On this cage, there's again two Teflon O-rings. They seal this cage into the housing and onto the seat. This particular O-ring here goes on the top of that seat, like so. And then the seat or the cage, I'm sorry, sits on the seat and seals. So inside this chamber, it looks like that. So there's your stack up and rack. So you can see there's a taper on the seat. That's where that O-ring sits. There's a larger face on the bottom of the cage. That sits on that O-ring. Another sealing ring, and the 3 shims. So that's your foot valve. So what are we looking for with the foot valve? We inspect the ball for any damage, dents, scars, and so forth. By the eye, it looks quite good. So to test that, what I do is I sit that back in the cage itself, or the housing, and I'll put the cage back in without the shims. Then what I suggest you do is push it all the way home, and it'll go down and sit on the seat. Now just tip some solvent in there and hold that nice and still and see if the solvent leaks out here. So if the ball has been compromised, the fluid will leak out of here. If the ball hasn't been compromised, it will maintain a seal and there'll be no fluid exit there. So that's a foot valve, primary foot valve. This here is your cylinder. So what you're looking for in the cylinder is to ensure there's no scouring up in the cylinder wall, because this is what we call static packings and moving packings. So that means that the top stack of packings remain in the one position, whereas the bottom packings, which are attached to the piston, they move in and out the cylinder. That's what causes wear eventually on the cylinder wall. So what you're looking for in the cylinder wall is, once we remove the piston, we're looking for scouring, and the scouring will be in a vertical sequence where it's carried a piece of contamination up through the cylinder wall, if the pump's managed to pick a piece of contamination up. And also too, if you're using high wear products, as I mentioned before, vinyl esters, calcium silicates, micaceous iron oxides, they'll tend to scour the cylinder wall. So how do I get that piston out of there? Well, remember what I said, we've reduced the torque on this particular piston by reducing the torque on the castellated nut. So now that we've reduced any pinch that the packings might have on that, we can remove the piston. Now, because it's hardened chrome, what you won't do is bash it with a hammer. That's a soft hammer, a brass hammer, that's fine. But also too, you've got to remember that if I hit that, I could damage the edge of that, and the collets won't fit on there. So what's the best way to get that out? Well, there's 2 ways you can do it. One is you can turn the whole thing upside down and hit it on a piece of timber, or just push on the pump and it'll slide out. Quite tight, so tap, 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 and that exposes the bottom of the piston. So can I get the piston out now? No, I can't. It's still a little bit awkward. So what would I do to get the piston on that last section out of the cylinder wall? Would I hit it with the hammer? Probably not. You still need something soft. So because we're on site and we don't have a beautiful brass drift to put in there, you can use the end of the screwdriver, and it's not going to take a lot to get that out of there. So because I don't have all the tools under the sun at my availability, that's all it takes. Now, you've just removed the piston from the cylinder itself. So what we're looking for on the piston is any premature wear. So what you'll need to do is remove your glove, and with your fingernail or thumbnail, you'll run that round the cylinder, the piston, to ensure that there's no scouring on the piston itself. So if there's any damage being sustained to the piston, what does it matter? Well, ultimately you're asking these packings in the top here to seal on this. So if there's any damage in this, the seal's compromised, because where there's an impregnation on the piston on the external face here, it undermines the ability for those packers to seal this chamber, this pressure chamber. So you'll check the piston to see if it's been compromised by any damage. Now in this particular case, this piston's in quite good repair, but it has a few marks here 1, 2, 3, 4. There's 4 little marks. Now, because they're not elongated in a vertical sense, they're just across there. So this could have been sustained from previous removal. And because they're only minor, and my thumbnail's only just picking them up, what I can do is with some wet and dry. What grit wet and dry will I use? 40 grit? 200? Ultimately what you're trying to do is just take the edge off that. So you would grab some 600 wet and dry, and with the wet and dry and a small amount of kerosene, oil, throat seal oil, any type of minor lubricant, thin lubricant, you can wrap wet and dry around there. And I wouldn't suggest you run it up and down the piston. I would suggest you do it in a rotational motion, up and down the piston, and just concentrate your efforts where you saw that mark. Remove the wet and dry and have a look to see if you have taken the edge off that particular damage. You won't pick it up as easily with your thumbnail then, and because it's only 3 little marks across this way, I'm happy to let that go. The other thing you're looking for in this piston is also too any significant wear from here to here, because that's where the packers run. So that's where the piston's running between the packers. So to check the wear on the concentric section of this particular piston, what I can do is make sure that I don't have anything near it that can damage it. With the appropriate packing kit or repair kit for this particular pump, and in this instance it's a 220cc pump, and it's an Extreme pump, so you can see here, repair kit Extreme 220. There's the part number, so it's quite easy to identify what's required. The book tells me, and that's the repair kit that I'm required to install to reappropriate the pump in its original status. So remove the packing kit. Now, because these pumps are designed to be repaired on site and in the field, they are designed to easily identify what's required. Now, it's a little bit grubby here. Would I put a new set of packers down on that? No, absolutely not. So with some clean rag, tip out your packings to see what you've got as far as packings is concerned. Now, this particular one is a leather and Teflon packing kit. So these leather packers seal onto the piston itself. Now there's 2 types here. There's PTFE, which is polytetrafluoroethylene, polyfluorotetraethylene, which are the black ones, which we call tough stacks. This is your standard basic pack. What's the difference? Why would I use a PTFE kit, a tough stack, as opposed to this one? Well, the tough stack's designed to be slightly more robust. So as I mentioned, when you're using products such as silicon carbides, if you're using products with vinyl ester in them or calcium silicates, they tend to be a little bit aggressive on the packings. So this standard kit here would probably not sustain that type of aggressive additive in the paint for any extended period of time. So I'd be inclined to look at what sort of product we're using, what packers I need to give me some longevity out of the pump. So in this instance, like I say, it's leather and Teflon packings. So how do they go together? Well, if I need to know how they go together, it's quite simple. There's an instructional sheet here that tells me how it's all repaired and where those particular items go. But to put it in context for you, because I know most of you armchair critics won't read that, the simple fact is that with this particular Graco pump, there's 5 packings top, 5 packings bottom. How do we rack them up? Well, because this is a leather and Teflon packing kit, we have to put them in sequence. So you have Teflon first, leather. Then you'll have Teflon second, and then you'll have a leather. Then you'll have Teflon again. Oh, what's happened there? It's smaller. well, that would probably be the piston end of things because it'll be smaller. So the larger ones are for the top gland nut, and they seal the top of the piston. So here we go, we've got Teflon, leather, Teflon, leather. We want one more. There they are. So can I just shove them in the pump? I need to soak these in that throat seal oil, TSL. Why am I soaking them? Because the leather needs to absorb that lubricant before you put them in place. Because if I put them in dry, they will prematurely wear and not seal on the immediate requirement. So by soaking them, what you're doing is you're conditioning them to the environment you're going to install them in. So how long would I soak them for? You need to soak them for at least 10 minutes to make sure that the leather has absorbed all that oil and lubrication. So in this kit as well, I've got some anti-seize, which I'll use on all the threads. And there's 2 new balls, and these are retainers. So what these do is they actually retain the seal or the packing in its original format and shape. So under pressure, as you can see, it holds the whole thing in its appropriate state. So the rack of packings I put together here, they service the top of the pump. The rack of packings for the lower end are the same. They all rack together the same way I showed you these top ones. Now that's leather and Teflon. So if I was using leather and Teflon, they would go in a cup like so, a very, very clean container, and you would put throat seal oil, TSL, throat seal oil in there and soak them for at least 10-15 minutes before using them. So the important thing is you keep all this together and keep it clean. So that's a leather and Teflon packing kit. What I'm going to show you now is a tough stack, a PTFE. So a PTFE, polyfluorotetraethylene, is the composition of the packing themselves, which will give you a little bit more longevity in relation to service life of the pump itself. So you notice that these ones are black. Notice these ones are blue and brown. So it makes it easy for us to identify what they are. And as I mentioned with these pumps, there is a set of packings racked together for you that work in conjunction with each other. So let's count the packings that we've got. We've got a retainer, 1, 2, 3, 4, 5. There's 5 there, okay? So 5 on the top, and there'll be 5 in this one as well. 1, 2, 3, 4, 5. Now, do I need to do anything significant with these before I put them in? Absolutely. It's the same scenario. So with those particular ones, the same deal. They go into, you don't have to worry about soaking the retainers, of course, but they go into the container and TSL on there, let them soak for a few minutes. What it does is ensures that in the seal itself, there is lubrication between each packing. It's important that there's lubrication there because when they come together and squash, that lubrication will ooze out onto, in this case, the piston. These packings, they're what we call chevron seals or sergeant seals. That's derived from the 2 lips that face the pressure. So you've got a conical or convex type shape and 2 lips. So those 2 lips always face the pressure. Now one of my learned friends did show me that the Graco insignia also identifies which way your packings go. So if ever you forget and you can't find the instructions which way the packings go, the G is indicative to the way or the support mechanism for your packings, which way they go in there. So the G facing down at the top represents the packers at the top facing down, and the G
at the bottom represents the packers facing up. So at the top, the G, packers facing down, packers facing up. So if you ever forget, just look back at this, and that gives you an indication of which way they go. Instinctively, you would use this, which is a packing repair instruction as to how it all goes together. That's the best way to do it. However, if you do lose those, just remember there's 5 packings at the top, 5 packings at the bottom, and the 2 lips always face the pressure. So after you've soaked these and you have the retainers, they're ready to go back together. Now just go back one step when I said that we want to identify the wear on the piston. So this piston, the packings at the top, as I mentioned, are static packers. So what that does is, or what that resembles is, the fact is that these top packs, or rack of packs, they don't move. They're sustained within the top of the piston itself, piston body, or the housing. So what we're looking to do now is we want to check to see what the wear factor is on the piston stem. So with this type of packing is the better one to identify the wear, because they're a lot more taut in the integral wall strength to give you an indication of wear factor. So what we do is we slide that down the piston, and then we follow it all the way down and check to see whether the gap is the same from top to bottom. As I mentioned, when these pistons wear, they'll get a step in them. So they'll come down and there'll be a step, then you'll see it's worn in slightly. So when you slide this packer down, you will see there'll be no gap, and then all of a sudden you'll see a big gap around it. So that identifies wear on there. How much is too much wear? Well, ultimately, if that packing is really loose and you can see a lot of gap in there, that means that when you put these packings back in that gland nut and you tighten that castellated nut to increase torque on those packings to make sure that they flare to seal onto the piston, it's quite a significant distance for it to be crushed to seal. So ultimately, you'll only get a very short life out of the packings because there's significant wear in this. Can you measure this with a appropriate gauge to see the wear factor? Absolutely. I'll measure the top, the bottom, and then take a measurement up through the stem to see what the wear factor is. But if you don't have a set of verniers, basically what you'll do is you'll use the packers as an indication for wear. So on site, do you have a pair of verniers? No, I don't. Ultimately, just slide the packing down the shaft and check for the gap between the inside edge and the piston itself to see what the wear factor is. In this case, the wear factor, the distance or the gap between the packing and the piston itself is the same all the way from top to bottom. So this piston itself, irrespective of having a little mark on it, which we've rubbed out, is in quite good repair. So there's still a lot of life left in this piston. So I'm pretty happy with that. On the bottom of the piston there's your second set of rack of packers themselves. So top packings, bottom packings, and inside, that's your secondary ball. That is a valve, so that's your secondary ball valve, which seals on the pressure side before it delivers out the airless paint line. So this has to come off the stem of the piston itself. So now we have to be very, very careful that we don't damage this. So if we're on site, what would we do? Because we don't have a vise, ultimately what you'll do is, with some rag or even a piece of cardboard, put it around this piston stem and you'll wrap it fastidiously to ensure that you don't sustain any damage to that cylinder. You damage that piston, if you damage the piston, that's it, you're in trouble, because you can't expect any longevity from the pump itself if you've damaged any of this. So with that wrapped up, what we'll do now is, because we're on site, we don't have a vise, you can use a large shifter to undo, or hold, I should say, hold the piston itself, like so. So you've got some means of support here for yourself without hurting yourself. Now, what can I use? Can I use a shifter to do that? Well, a 12-inch shifter, as you can see, struggles to get over that. So I don't have anything bigger than a 12-inch shifter. What do? Nothing else. So sometimes we don't have any choice but to use items like this. But just remember, if you use Stilsons or something that's aggressive on this metal and the integral aspect of this, you can always dress it and clean it back up again to make sure that there's no sharp edges. So on site, when I haven't had a vise, I have no choice but to use a pair of Stilsons to undo this. Now this will be tight because when it's assembled with a little bit of Loctite. So what you'll need to do is you need to crack it. So there's no point in trying to push it to get it undone. So what you need to do is crack it. So what you'll do is you'll bring your hand up and crack it undone like so. Now be careful with the jaws that they don't punch back onto this edge. And as I say, if you have to, get a file and just tidy this back up again where you had the jaws of the Stilsons. So slide the Stilsons out of the way. And now you can undo the piston stem, which has the existing packings, a retainer, a threaded section, and this is now as a seat, and out of the piston comes the ball. So again, it's a 316 ball that's had a fair bit of wear or exposure, and you can see that it's no longer shiny, as you can see in these by comparison to the kit. So there you go, there's the difference. Look at the difference. So this one's done some work. Again, I run my thumbnail around this to find if there's any wear in it. Why would I bother doing that? Because I have a brand new one here. What we're looking for is if there's any significant damage to this ball, that means that we have to check to see if there's any damage in the seat. So it's a tungsten carbide seat. Is it possible that I can damage it? Absolutely. A piece of blue metal under compression is enough to impregnate the seat itself, so it leaves a mark in the seat and this ball no longer seals in there. So I can check the seal on this ball as well. What I'm looking for is to make sure that the seat hasn't been compromised. So primarily I'll still use the same ball I took out of there. I can screw that back in there. You don't need to tighten it up with torque on it. The torque on these is 60 foot-pound when you are in a workshop environment. So now stand that piston up. Now I can use this oil if I wish to. And you see it floods out there. But what I'm looking for is it coming out the bottom of this? It's coming out the edges here, out of these venturis, but it's not coming out of the center. So just to make sure that you understand that, if I put the screwdriver up there, move the ball, there comes the oil. So the ball's pretty good. So the seat hasn't been compromised. If, however, that ball did leak, what you would do now is you would take that ball out that has been compromised, put it to one side, put the new ball in, put it in the retaining cage, screw that back in, and do the same procedure again. And if it continues to leak with the new ball in there, you know you'll have to wipe all this clean and ensure that there is no damage there. If you do find damage, that renders this inoperable. There's no point in putting it back together if that's leaking out through the bottom of it. So now what we need to do is take these packings off here. What's the easiest way to get them off? Well, they're caked in paint. Do they come off easily? Of course they don't. So would I use a screwdriver and give them a good old hit with the screwdriver? Probably not a good idea. What I do is, if you put that piston stem back in there, now what I can do is put your foot on the shifter and then you'll open these jaws up so that what you're going to do is you're going to twist those packers on there. So by twisting that, I've broken the paint seal. Once I've broken the paint seal, then it enables me to actually remove the packers and the retainers. Now, sometimes they'll move easily. You might have to repeat that procedure several times to ensure that you've got them to release from the stem of the retainer. So I can move the packers, look at that, no problems at all. Take that back off there, pinch, the retainer on the top, keep twisting it round. You've broken the seal, take it from the spanner. Can I get it off now? It's actually moving, and there you go. So you've broken the seal and you've released the packings off the stem. So there's your retainer, your packings, another retainer, and there's the stem. So all this has to be washed now, cleaned, and that thread has to be extremely clean with no retentive rubbish in there so that it can be screwed up in there with a small amount of Loctite. So these here, in the bin. That's the end of that. Don't leave those existing packings laying around. If you leave them laying around, there's a good chance that you'll get them mixed up and put them back in the machine itself. So get rid of them. Don't need them. Okay, so we've removed the packings from the end of the piston stem. There's another set of packings we need. So remember what I said about this piston. You have to guard it from any accidental damage. So what I suggest you do is wrap it up and put it out of the way. The packings that are in the top of this, now this is what I was talking about, a castellated nut. It's actually a well, and inside the well holds the oil. So the separating oil sits in this well. That's what that does, and lubricates these top packers. So they're actually wetted all the time. Now here's the retainer, and inside here, of course, is the remainder of your packings. Like so. So what you do is, as you remove the packings, you inspect them for wear or anything that's unforeseen, such as a crack in the packings or a split in the packings, because if you find that there's a big gouge in these packings, you'll find that normally the sacrificial aspect of damage to those packings is sustained within the piston cylinder wall itself. So just make sure that if you find something untoward there, the remnants of it will be here somewhere. So in this case, we've already inspected the piston. We know that it's in good repair. So all we need to do is get the rest of these packings out. So there's the retainer, there's the packings. Now you can see they've had paint up through them. And also too, they will have sustained a bit of wear. Now, with these chevron seals, if they've had heat in them, what you'll find is they've umbrellaed on the inside and folded over. So these pumps will only sustain 20 seconds maximum of free pump. What I mean by free pump is there's no fluid in this chamber, and the piston is just running up and down through this and getting these hot. So 20 seconds, it's all over. You know that you have to change the packings. So you've compromised the integral strength of the packing and its ability to be able to seal onto the piston by getting it hot. So that they won't sustain heat of any consequence. So if you run the pump dry for any longer than 20 seconds, I can guarantee you that you've compromised these packings and they'll need to be replaced. So remember what I said about the old packings? Put them to one side so that you don't get them mixed up with the new ones. So you must put them to one side so that you don't get them mixed up. Now what have we got here? What's left? We've got this here is a keeper for the castellated nut and the oil well. So do I need to take that out? Do I need to pull this out? If you have trouble getting the packings out of there, 9 times out of 10 you'll have to remove it. But the problem is too that this has a seat in it. The seat is for that retaining ring to sit on. So behind that there's an accumulation of dried materials that need to be cleaned up. So basically what you'll need to do is remove this. Now 9 times out of 10 this is quite tight. So make sure that when you use a C-section spanner that you've got good purchase on it. So before I try and do that, what's in the way? Well, the filter stem is in the way, so I need to remove that. So because you've loosened it previously, you'll take the keeper, the filter, the stem, put them out of the way. Now you need to undo this. So with this area free, now I can utilise the bigger spanner, C-section spanner, and get a good purchase and have it towards the base so it won't slip off and hurt me. So you need to crack that. So by pushing on it with an immense amount of torque, you still won't undo it. So you need to crack it so that it's cracked off the thread where there's an accumulation of paint in behind it. So what you'll need to do is appropriate yourself so that you can keep yourself free of any harm. And what I suggest you do is you can use a pipe on this, a length of pipe, which will help it, or just shock it to start the thread. Undone, like so. And away you go. Now this has to come out because you need to clean in behind it. So how far do we go for a repair? When you put a new set of packings in, it's imperative that you clean everything, because any remnants you might disturb by loosening all this stuff, contamination such as this, could undermine the new packings that you put in. So it's imperative that you clean all this and make sure that it's all lubricated prior to reinstallation. Now, you'll see in here, there's remnants of old paint. So you'll have to make sure that you wash all this out. The different seals are identified as well by colour. So as far as your instructional leaflet is concerned, all of these are identified in the reinstallation and repair guide. So if we take this out and clean all this, there's one other. Now, if I'm on site, the chances of me getting this out of here, out of this cast housing, are quite remote because it's very tight. The only time I'll need to remove that is if there's scouring in the cylinder. So there's two aspects to this. Does this have to come out? From a common sense perspective and a repair in an appropriate manner, yes it does, and I'll show you why. So to remove this, you'll need quite a substantial pair of Stilsons or a large shifter to be able to get on to the cancellation of this particular cylinder. Now, in behind this cylinder, there's another O-ring on the top of the cylinder, and it's quite a substantial O-ring, and it's easy to identify in the packing kit which one it is because it's got a thick wall. So that thick wall O-ring goes at the top of the cylinder. So the problem is that there's a cavity in the top of this cylinder wall, and paint accumulates around the top of the cavity, on the taper, and down into the thread. So sometimes they're quite difficult to get undone. So how do we get this undone? I don't have a vise in sight, I don't know what to do. What you can do is, you can attempt to undo it, and as you can see it's quite tight. So what I suggest you do is find yourself a pallet or something that'll hold this for you so that you can put your foot on top of it and keep yourself safe without hurting yourself by undoing it. So to remove this cylinder out of the housing, this cast housing, I need to undo this, and it'll be quite tight. So the one thing you've got to remember is that there's a retainer in here, and it's a pin. So the pin fits across the slotted section of the housing. So I need to take that pin out. Now sometimes that pin's tight. That's all well and good. I can tap it out, or can I? Sometimes paint will accumulate around the pin entry and exit. So by hitting it, you've got to make sure that it is going to move, because what I can do is damage that pin and burr the end of it over so it doesn't come through the cast housing. So in essence what you do is give it a gentle tap to see if it moves. In this case it does, good. If it didn't move, what I'd be inclined to do is wash it up with solvent, and I'd scrape any additional paint off around the edges. Very careful not to dig into the pin. Give it a clean up and give it a wipe, like so. Now that pin has a taper on the head to start it back into the hole. So if I give it a slight tap, I can pull that pin out, like so. So wipe the pin up, put it to one side, roll this back over. Be careful you don't break that stem off this capillary tube. So what I need to do is get that shifter back on to that cancellation. So with a large shifting wrench, see if it moves now, and it does. So the interesting thing with this particular concept is that this cylinder here actually turns to accommodate that pin. So if you screw this all the way home when you reinstall it, you'll find that you can't get the pin in, so you'll have to turn this back to the flat section so that the pin slides past this flat section like so in the housing. So now we can undo this. So by holding it up, don't damage this thread here, be very careful of that. So stay well up the housing so that you're away from the thread and don't damage anything. So getting the shifter back on there, like so, and just continue to undo it. Can I undo it by hand from here? Yes, I can. So wind it out. Now remember what I said, it's cast. So as you take this out now, like so, and there's the big seal I was talking about. Now, look at the thread difference. Coarse, fine. Because it's a fine thread, don't drop it and damage it, the thread on the housing. So what we need to do is clean all this up. But now that we've got this out, it enables us to clean all of this in here, all the hidden aspects of the casting, make sure it's nice and clean. I suggest you don't hit any of this with a screwdriver because that seal has to seat on that taper. What we're looking for now is any wear or scouring within the cylinder wall. So hold the cylinder up and have a look inside the cylinder to see if there's any scouring. The scouring will be vertical, it won't be horizontal. The scouring will be vertical, as is the action or the actuation of the cylinder or the piston itself. So the piston comes in and out like this, hence the scouring will be in a vertical stroke. So by running your finger around inside the cylinder, you can establish whether there is any scouring. Now if there is significant scouring, I'm on site, what do? Well, I need my pump back. As I suggested earlier, some 600 wet and dry, and you'll take the edges off that just enough to sustain some sort of life or longevity from those packers until you get a new cylinder. But I suggest if the cylinder is scoured, you replace it. Now you'll notice I've pulled that out of there. There's a taper, and then it goes into the barrel. On the other end, the foot valve end, there's also a large taper, and it goes onto the barrel. Now there's a trick here. When you reinstall new packings on this particular piston stem and you're ready to reinstall it, remember what I said about these packings. They're chevron seals, so they're lip seals, two seals facing the pressure. So gently sit that on the ground. Now the packings go in this way, like so. So the two lips up face the pressure because the piston goes up that way, because that's its pressure stroke going up. So when it goes up, the ball seats in the seat itself. The packings pick up the rest of the fluid in the chamber and send it up towards the outlet for your hose. So these seals, because they're lip seals, if I put them on the piston, like so, now this is purely for a demonstration purpose, you can see that those lip seals face up. Now, if I didn't take that out of there, I would be pushing this back through the pump as such. And before I attempted to do that, I would put this base nut and castellated nuts with the packings back in there to guide the piston up to the end of the stroke and keep it straight for me so that I'm not kicking this to one side. The reason I'm showing you this is, look at these chevron seals, they're facing the pressure. So if I try and shove them back into that taper, I'm actually pushing them backwards. So what I'm doing in essence is opening those lip seals out that way. So the force is coming from the taper back this way. The appropriate way to put these pistons in the cylinder is by, with the new packers on, putting them in that way. So primarily that taper is facing the non-pressure side of the packings, and it doesn't tend to tear the face of them open. So that'll ensure longevity of your pump. So that's the appropriate way to put them in. But as I said on site, if I couldn't get that out and undo that, and the cylinder was in good repair, that you have no alternative but to actually put it back in there. Now, when you reinstate all this and you put 60 foot-pound of torque back on this and screw it up, those packers will be kept in a sequence. The sequence being the retainer, the packers, the retainer. So they'll keep them harnessed so that they can't slop around like this. And there's a good chance that you can get nice and square to get them back up into the piston cylinder itself without damaging them too much. Sometimes you have no choice. But just remember to be gentle with the way you do it, and don't damage this piston, and don't damage this by dropping it on other alternate parts prior to reinstallation. So on site I've washed everything and I'm going to put it all back together. So the one thing to ensure that I've divorced the old packings from the new ones. I've got everything I need here in front of me, and if I get lost, if in doubt, read the instructions. The reason I said that you have to keep this stem nice and clean is because what we're going to do is, you notice when the rack of packings go in there, there's no spring washer. So you're relying on this thread to go back up into the end of the piston and hold all of this on the end of that piston under maximum pressure. So what we do is we clean this up. This thread is impeccably clean, and we utilise a thread locker. So what I use is a thread locker such as 243. So how do I remember that? 243 is blue. If you use the red one, there's a good chance you won't get that a red colour thread locker. You won't get this undone easily. So all this does is just holds it for you. So irrespective of doing it up to 60 foot-pounds, that is just another keeper or a means of retaining that end cap in that piston to ensure it doesn't come undone. Because believe me, if this comes undone under pressure, you'll smash all the bottom out of this pump itself. So that air motor that drives this has the capacity to shove all of this out through the bottom of the pump. So that's why we ensure when we put it back together, safety first, we do it properly, follow the procedure and ensure that everything's tight and done as per the manufacturer's recommendations. They write the recommendations for a reason, and that's why we follow them, to ensure that when we put this back together, it's done correctly, appropriately, and it's safe. Okay, so now we've cleaned all these parts up fastidiously to ensure there's no remnants of paint. The oil well is clean, primarily because that's lubrication. It's imperative that it's clean so that the oil that is put in there is lubricating with clean oil and no contaminants. That's our 3 shims for the bottom of the foot valve, the retainer, the seat, and remember what I said, there's a taper on that seat, so it's a double-sided seat. Normally what I'll do is I'll pick the side that's been used because it's nice and concentric. If you wish to, you can use the other side of the seat. Just make sure it's nice and clean, and test it when you put it back in to make sure that the seat is sealed. So reassembly, where would I start? What on earth do I do? Well, basically what you need to do is get the fundamentals back in place. Now remember what I said, if you can't get this cylinder off the main body, what you're better off to do is put the piston back into this main body or cylinder. In this instance, we can do it the appropriate way because we have managed to remove it. So as far as this is concerned, we start putting our O-rings back on. Now you see that the ringland that these O-rings sit in is beautifully cleaned and all our threads are clean. So do we just put it back in dry? No. What you need to do is you can use a bit of Vaseline. You can, if you want to, use a bit of anti-seize in the O-rings. A bit of Vaseline's best. And just a smear on the edge, run the O-ring round, like so, and then flick it home. So by doing it that way, you've got a nice seal in there, like so. So there's no point in over lubricating any of it, because ultimately when we put this all together and complete the reassembly, you have to flush the machine out to get rid of any excessive lubricants, because you don't want that in your paint. So now that we've put that seal back on, that cylinder, needs another seal on the bottom of it, which we'll do upon the last section of reassembly to ensure that I have put it in place. So the one item I do need to put back together is the piston, because that's the primary reassembly. So the piston, we've checked that, we've made sure it's not damaged. So what we'll need to do is put the packings back on to the piston stem itself. So which ones do we use? Well, they're too big, so they must be the top. Is that the right size? Yes, you see, there's no slop. It fits on the stem beautifully. So which way did the packers go? Can you remember? That goes in that way. So which way do the packers go back on? Well, the packings, you've got a retainer, and then your packings which have been soaking here in throat seal oil, you've got 5 large and 5 small. So the 5 packings that we mentioned previously, there they are, the 5 packings. They've been soaking in throat seal oil. Always soak them, so that what you can see there is the lubrication has been pushed up into the side, inside the chevron seal itself, so that they're well lubricated and ready for reassembly. So that's your retainer. Your packings go back on the stem, like so. So ensure that they're all home. That means they're all married together appropriately, so there's no gaps. They all push in home, and you can see that there's no gaps between any of the packers. So the last item I need is the retainer. So would it be this one? Of course not. You need a D-shape retainer for the other side of it. So you've got the top packings, and you'll need the retainer for the bottom ones. So there it is. See the shape of that? The concentric to fit the packings themselves. So we slide that on there. Now the next item of reassembly is putting this back into the piston itself. So what we do need to do is now we need to wipe this with a little bit of solvent, because we're going to put some Loctite on there to ensure that it's retained within the stem of the piston itself. So with a little bit of solvent on a rag, I'll give this a wipe. So I don't wipe the lubrication off the packers, I just wipe the thread stem itself, like so, and it's ready to reassemble. Now, as far as Loctite's concerned, less is more, so that you only put a small amount on there, and that's more than adequate. Because what will happen is when you thread that in, because it's a fine thread, it's NPT thread, because it's only a fine thread, that'll carry that remnants of all that dollop right around the thread. So if you put too much on there, what will happen is it'll encumber the thread and you won't be able to get it back out appropriately. So there's one thing missing here. That's a seat. That's a secondary seat. So what we need is in there is the ball. Now the other reason I don't put too much Loctite on there is because the Loctite can run back onto the edge of the seat and actually stick the ball to the seat. So by doing it that way, I can see now where the Loctite is. I can see where the ball is. The thread in the end of the piston is clean. All the venturis or ports or outlets are all clean, and I reassemble it. Now what I do like about these pistons is they're all identified. So here you are, it's a 220cc piston, and it's a 220cc packing kit that we're utilising. So that's a PTFE. So just to go back on that again for you, check that you put the packers in the right way. There you can see the conical section, and the sergeant seal or the chevron seal is facing up. So this is the pressure chamber here. So we screw that back home, like so. Now, remember I said it's torqued to 60 foot-pound. Well, if I had a torque wrench on site with me, I'd be really grateful, because then I can ensure that I get it to 60 foot-pounds. What happens is that this particular piston stem, the thread has a shoulder, so the thread actually runs out. So this thread in here is what we call a parallel thread. It's not a taper thread, so it doesn't go up and pinch. It actually goes up and stops at the end of the thread, and where this retainer kisses the foot of the piston itself. So where the two come together, how do I find out it's 60 foot-pounds? So what I need to do is place it in the vise. So I placed this in the vise, so I put the stem in the vise. I would never put the shaft in the vise because I'd damage it. Even if I wrapped it with rags, cardboard, whatever, you'll damage it. And besides,
it's because of its shape, it'll tend to spin around in the vise anyway. You'll damage it. So we've placed the bottom of it in the slotted section of the piston stem. We place that in the vise. And we've got soft jaws so that we don't damage anything. If you're on site, you'll use the shifting spanner that I showed you how to remove it. So then with the shifter, adjustable wrench, we'll tighten it up. So what we're doing now is we're actually putting torque on those packings. So 60 foot-pounds, in essence, when the thread runs out or stops, there you go, it come up against the shoulder. So there it is there, up against the shoulder, it's stopped. So what I'm going to do now is just apply a slightly more amount of torque to this, and that's it. So just to show you again, there we are, the torque comes up, it's starting to touch, I'm feeling the resistance, and then it's stopped. So the thread's got to the end of its stem and it's squashing that retainer. So with a marginal amount of torque, I've increased the thread tension on there so that the packers now are all compressed, and now all the lips on the outer section of these seals are protruding. So the protrusion is on that edge there, this particular edge here. So that edge is now sticking out of there. Why? Because that's the seal or the wiper part of the piston itself. This actually does the job and maintains the pressure within this cylinder chamber. So now that we've done this, we can remove it from the vise, hold on to it so you don't damage it, slide it out of the vise, and there you are. So you've got your packings and the ball. It's imperative you do this to make sure that the ball's free and you didn't get any Loctite on it. So is there anything I need to check before I install it back into the cylinder? Basically what I do is, it's a keepsake to make sure that the ball is sealing. Set the ball, hold it up like this, you've got oil around it. So you see the oil running on the outside. If I push the ball up off the seat, there should be oil come out of the center. And there it is. So the ball's actually seating in there. So now you know you've got a clean item, clean seat, new ball, new packings, piston's not damaged. The little mark that I had on there before, I removed with some wet and dry so that it doesn't catch anymore or damage the piston packings. So now that that's ready to be reassembled, remember what I said. If you're on site and you have no choice but to put it in this way, you can see now that there's the taper, the big taper, and the piston goes up in there like so. So on site, what I do is, on a piece of wood, drop that on, and that'll push the packings back up into the cylinder. But because the packings are facing up, what I wish to do is put them in the appropriate way. So being very gentle, push them back down like that. So what do I do from here on in? So how do I keep that straight? How do I stop it from kicking to one side? Can I just use a hammer on the top of it and bash it in there? It could go in crooked and scour the cylinder. So the important thing to remember is, in a workshop environment, I'd press that back in there. We're not in a workshop environment, so what do? How do I appropriate the reassembly of that? I can't screw that back in there because it denies me access to it to do it this way. So what I suggest you do is, with a piece of timber, and I always use timber primarily because I don't want to damage this where the collets go on. So I can hold this straight like so and just drop it into there. Now, if I'm not careful and don't hold it straight, it'll actually be pushed in there crooked. And if it's crooked, it'll jam and you'll never get it back out again. So what I've done now is I've started it back in there. So how do I complete this sequence? Well, what I can do is, I can put the piece of timber on the top here, and now I can hit it so that it goes back home. So remember what I said, this is the appropriate way to put it in. With a press, it's much easier. So by doing it that way, what you're doing is you're eliminating the face torque on the packers and pushing them in the right way, the correct way within the cylinder. Okay, so we've got the piston back in the cylinder wall without damaging the packings. We've put our O-ring back on there. Now we need to put the cylinder back in the big housing. So you can see that there's a clean seat here. That taper is nice and clean for that O-ring to come up against.
So the important thing to remember is I need to put some lubrication on there so that if I need to pull it apart at any stage, there's something in there so that there's no corrosion can eventuate within the threads. So in that kit, what you'll get is a packet of anti-seize. So the anti-seize is utilised on these bigger threads so that I may be able to get the things undone at a later date. So here's the anti-seize. It's nickel cadmium anti-seize. Apply it to the thread like so. If you wish, you can push it into the thread. Now, I don't have to do it round the thread all the way, but what I do need to do is put it on the leading edge so that when the thread starts to marry with the cut in here, it takes that anti-seize with it. Would you put copious amounts on there? I wouldn't be inclined to, because it does consolidate and it can make it difficult and bind the thread. So that's more than adequate, what I've applied there, more than adequate. So the O-ring itself, what I'm inclined to do is use a little bit of Vaseline, because the Vaseline is an excellent lubricant and it'll squash in behind the O-ring so that when I wish to remove it again, the ringland, which is the recess in the cylinder, is nice and clean and easy to clean if there is any paint remnants in there. So now this is ready to be assembled in here. Can I do the same on this side? Absolutely. Apply a small amount of anti-seize, a small amount of Vaseline on that tapered edge so that I'm not putting this O-ring back in there dry. If you reassemble it dry, you'll actually tear the O-ring and it no longer seals in there. It's imperative that this one seals because this is the pressure chamber itself. So now I can put this cylinder back in this housing. So all this is clean, all this thread's clean, so while I'm here I can put anti-seize on all of these areas, like so. Now one thing you can do is you can wear gloves to reassemble these items. Luckily we have cleaned all of the paint remnants on this and there's no solvents involved, there's nothing that can hurt me and contaminate my skin. If you wish to wear gloves, please do so. So all these edges here, they need a little bit of anti-seize on them. Same with the threads. So there's no need to go overboard with the amount of anti-seize you put on there. So back to this section here. Now I can slide that back in there, but look what can happen is if I'm not careful, I can damage that piston on this housing. So what I suggest you do is, back around this side, if you put this keeper back in, put an O-ring on the keeper, so with a little bit of Vaseline in the ringland, like so, slide the O-ring on there, like so, a little bit of Vaseline, bit of anti-seize again. Don't overdo it with the anti-seize. Slide that back into place. Now you don't have to do it up tight. What we're looking to do is hold that piston straight and we don't damage the piston. So what's missing out of there? I put the keeper in. What do I need? Probably some packings would be a good idea. So here we are, some we soaked earlier. Remember what I said, 1, 2, 3, 4, 5. So that's a pressure chamber underneath. So what we're looking to do is make sure that the chevron seals face the pressure. The two lips face the pressure. So can I slide them straight in there like that? No, I need a keeper. So because they're facing down, the keeper faces that way. So the easiest way to do this is with some Vaseline on your keeper, like so. Slide the keeper down in place. Then you can put your packers in there. You can put them all together if you want to. But the one thing you've got to remember is that they all must go home and it must be square. So if you slide them in with your finger like so, you've got to run your finger around the inside of them to make sure there isn't any gaps. So if you're happy that they're square, happy days. However, if you think to yourself, no, I didn't get it right, start again. Just start again. So take the keeper back out again, the retainer, slide it back into place. Be careful it doesn't flip over on you. Make sure that it's facing up. And then if you wish to, you can do them one by one. Slide them into place and ensure that it's gone all the way home. One by one, ensure also it's gone all the way home, and so on, until you get to the end of the rack of 5 packings and slide them all in. So, are they all the way home? Just kick it up to one side and have a look down inside the barrel to see that they are all the way home. One other thing I need is another keeper. It doesn't hurt to put a little bit of Vaseline on this keeper as well, and a little bit on the inside of it. Now, before I put that one in there, because this piston is going to come through these keepers, what I'll do is I'll put more Vaseline on the inside of that, so that this has got some lubrication to be able to come through the packers without tearing them or moving them at all. So with lots of lubrication, and you're thinking to yourself, this is crazy because he's going to put paint through this. Well, ultimately, like I said, upon any repair, you must rinse this out with solvent now, because you cannot put this straight into paint. The other aspect of it too, of course, is that you'll be running solvent through it to ensure it works before you even contemplate putting paint in there. So now we've got this lubricated, we've got a retainer in there, and we gently slide that in there, gently, until it comes out the top. There it is. Look what's happened. Oh no, the packers have come back out again. What's missing? Slide it back out, like so. The packings have come out, so ultimately what's missing? Have the packings moved? No, they're all still there. Slide the retainer back in, and then we want this item here. Now look, there's no O-ring on this one. All it is a keeper. So what this one does is, it presses up against our packings and keeps them nice and tight. So ultimately what happens in that chamber is, this comes up and squashes onto these packers. So this is sitting on the seat, and the packings are torqued up with this nut here. So this castellated nut is the oil well, which gives lubrication down through here and into these packings. And there's the keeper. So we reinstall them again. Put the keeper in first, or the retainer. Put your packings in, like so. Have I pushed them in square? No, they're not starting square. Pull them back out again. Start them square, push them back home, like so. Make sure they're all home and square and kissing each other, and the gap from the top of that taper to the top of the packing should be about the same. Have a look. Yes, it's all the same. Put the retainer back in. A little bit of Vaseline on top of the retainer, primarily because we want that to be lubricated, so when we tighten it up, it doesn't grab on that keeper and twist it around on the packers. So the only other thing we need for this one here is a little bit of anti-seize, like so. Doesn't hurt to put a bit of Vaseline on the end of the stem here. So you can see I'm big on that, on lubrication and anti-seize, so that I can get the thing undone again. So now what we're going to do is we're going to screw this down onto the packings. So it'll go to the retainer and kiss. There it is, like so. Now the one thing I advise you to do, see how this is loose? What I'd be inclined to do is, without the piston in there, grab your C-section spanner and tighten up the base. So now what you're doing is, you're making that new O-ring squash into the taper. So you'll find that there'll be a little bit of resistance there. And there it goes. It's just gone past the taper, and now it's going to seat. Do I have to do this up extremely tight? No. What you'll do is you'll do it up and nip it up. So there it is, it's gone home, and that's more than enough. Now, when I screw this up or down, this bottom one, this bottom castellated nut, the base for the packing holder is not moving. So there we are. So with no tension on the packings, because remember, if I screw that up real tight, I'll squash the packings and I won't get the piston through. So with no torque on the packings whatsoever, put your pump body up on its side, very gently, put your finger in there so that you can feel your piston come through, like so. Piston slides through the packings, and there we are. It started in the barrel for us, and we could do this up. And the piston's poking through there. I haven't damaged anything, nothing's damaged. So now that I've started this back up into the body, I need to do it up.
So ultimately I can do that up by hand until I get to the nylon O-ring. Once I reach the nylon O-ring, that means it's hitting the taper on the seat, and I'll need a little bit of extra tension on it or torque to be able to squash it into the taper. So wind it up, and like I said, it's a fine thread. This is coarse, that was fine. So therefore it'll take quite a bit more to wind it into place. So what I'm going to do is, I'm just going to torque this into place by squashing that O-ring. So it's not going to take excessive force to do that. So I'm squashing the O-ring into the seat now, like so. Slide it back over, and there it is, it's back in the seat. So remember what I said, there's a pin that has to go through here and marry with the flat section of this particular cylinder wall. So how do I find that? Well, what I need to do is apply some force now until it has a sufficient torque to either flatten it out or bring it back. So the beauty of this is I can now turn this cylinder wall in the housing according to the taper requirement. That seal is going to seal this cylinder up in there, and I need to get that pin back in, because this pin is the only keeper for this entire cylinder wall. So the flat section of the cylinder needs to marry with the pin. So you'll just adjust it round until you get the flat section to marry with the pin without damaging that thread. That looks about right. So I don't damage anything, gently sit that there for the moment. Now this pin, what I suggest you do is definitely put some anti-seize on this pin, primarily because it is open to the weather, it is in a piece of cast, and it does have a tiny little ball bearing in there which has a spring under it. So we want that to depress and go into that particular slide section or flat section of the cylinder wall. Now if I tap this, there's resistance. So just back it off a fraction and make sure that you're going to pick up the flat section. Now this is something I suggest you take your time with. Don't try and rush it, because if you do, you'll just ultimately end up bending the pin. So just turn it back until you can get what you think is about straight, and try again. Tap, tap, tap. There's no resistance. And just to ensure there's no resistance, what you can do is just keep moving this back and forth. Any resistance? None whatsoever. There you are, as easy as that. So this pin does have a keeper, and it's hanging on the stem bolt, and there's a little retainer goes on that. So it's a bit of 316 wire that holds that in place, so that if you do take the pin out, you don't lose it. So here we are, we've got the piston back in. Now's the time to be very careful of this particular ringland. So what I suggest you do is, now that you've got all that weight and it's top heavy, is put a piece of rag under there so you don't damage the bottom of it. So we've got our tension gland nut here that we need to put some tension on. How much tension do we put on there? To be quite honest with you, on a new install like this, you'll nip it up until you feel a fair bit of resistance. That's plenty. Once you've run this for the day, you will check that tension again with no pressure on the cylinder, because if there's pressure in this chamber, you won't be able to turn that anyway. So with no pressure on this, by dumping the valve, you release the pressure in the chamber, then you've got some chance of pulling some torque back on those packings. So what else goes in there? Well, of course, once we install it, we'll put throat seal oil in there, and that will lubricate those packings. Now, in the kit comes all these 3 different types of dust seals. Which one do I use? Well, basically what you'll find is this one's too small. Does that fit anything? No, not really. Does this one fit? It's got, again, it's a chevron type seal, but it pushes into a ringland. So all we're doing is we're pushing it into the ringland, and you hear it click into place. Click, 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 there it is. So it's just a dust cap. That's all it does. It's just a dust cap, and you can see the 2 cutouts there. That's how you can lubricate it. So we put a little bit of lubrication in there. There's no point in filling that wet cup up
and trying to put it on the machine, primarily because it'll all run out. So the one thing you must remember is to lubricate or complete the whole process by filling that well with oil prior to operation. So if we spin it around, we've got our filter cavity. The filter we've cleaned. Remember, the stem must be clean. There you are. All the flutes are clean in the stem. The filter's clean. The one thing I have done though is I've touched it with Vaseline or lubricant. Does it matter? Not really, because I still have to flush all that lubrication I put on the piston, the packers. So I can put this back in because I know that I'm going to flush the whole thing with solvent. So push it home. Remember, the spring inside this cap has to be free and be able to push that into the seat. Now the one thing you can replace here in this kit is that O-ring itself. So what's the easiest way to get that O-ring off? Can I use a knife? Can I use a screwdriver? With a bit of a screwdriver, have a bit of a dab at it. What about a hammer? Give it a bash. If you try all those, you'll damage that ringland edge again, and again, the pressure will escape out that edge. So if you can't get it off with your fingers, what I suggested you is use a small screwdriver or a pick and get underneath the O-ring and flick it off. Ultimately, the majority of them will come off with your fingernails. So reassembly, make sure those ringlands are nice and clean prior to putting your new O-ring back on there. So there you are, nice clean ringland, a little bit of Vaseline, slide that round into the ringland itself, grab the appropriate ones. So remember what I said, if you take them off and they're the second-hand ones, get rid of them and put the new ones on. So here we are, a new one, nice new O-ring. So do I hit it back on there with a hammer? I'll get that back on there. Not at all. Just use applied pressure and it'll click into the ringland. There you are. So now I've put that on there. What else do I need? Well, let's go back to the anti-seize that came with the kit. It's silver anti-seize. Slide it onto the thread like so. You can put the anti-seize up on that O-ring. I prefer to use a little bit of Vaseline. No need to put excessive amounts on there. So there you are, it's all lubricated. A bit of stuff in the thread, that'll squash into this marrying thread, like so, and away I go. It'll go all the way to the new O-ring and then it'll stop. See, all the way to the O-ring and then it stops. So how do I get it past that? Well, what you're going to actually do is you're going to squash that O-ring into the taper again. So being very careful of the end of your pump. Use your C-section spanner and away you go, tighten it up. So you notice I put all this back together before I put that back in there, because how much would that impede progress if I'm trying to do this up with that there? So the filter housing is the last thing. You put it back on the top of the pump, like so. Now, is there any need to fill this pump with paint or solvent or to prime it? Absolutely no need whatsoever. The pump itself, what you'll do is, now you've done a new installation or a repair, is that you'll make sure that when you start the air motor for this pump, it won't suck it up immediately. So you'll do 5 or 6 revolutions of the air motor itself to start the pump sucking the material into the pump itself. You can pre-prime the hose that feeds this. You can fill this with solvent to assist. So we will more than likely do that before we proceed with trying to utilise the pump itself. So another O-ring goes on this one here. What did I need? I need some Vaseline in there to ensure that the ringland's got some lubrication on it, and check this one for damage and make sure there's no impregnation or dents in that ringland seal environment. So there we go, we slide the seal back on there. So look, all you do is you start the seal in the ringland itself, like so, push the torque to the face of it and click it on. Simple as that. So that one's ready to reinstall. So what I need now is just the foot valve. So we've got a foot valve. Here's one we prepared earlier, nice and clean. So I need back in there, I need a seat, which we've inspected, checked, make sure the taper's clean, the ball sits in there well. So we put that back in the housing. See, because it's nice and clean, it slides in there easily. Now what else we need is the keeper and a ball bearing. So the ball bearing goes in next. Does it matter if I get Vaseline all over the ball? Not really, because we're going to suck up some thinners before we start. So again, put the ball gently in the seat, hold it up like so. Yes, the ball sits in there centre beautifully. Now with this one here, there was 2 O-rings on there, one at the bottom, one at the top. I've slipped that one on there. We slip one more on there, so what do I need? A little bit more Vaseline in that ringland. Slide it around the ringland like so. Grab this and slide it on. Click, there it is. So there's the 2. Now with this particular one, what I do is I use a little bit of Vaseline around those. All good. What I suggest you do is use a little bit of anti-seize down this bottom one as well, because it'll impede the development of paint down the bottom of this area, because this one can be really difficult to get out. So say for example I turned that upside down and bashed it like you saw me do to make this shoot out. If you have a massive build up of paint around the top here, what you may find is you may have to put this in a vise and take this elbow off, and then with a drift, hitting the ball only, not the seat, you can drift that back out through the top. You'll mainly find that if the machine hasn't been cleaned appropriately during the course of its life or the course of the packers that now need replacing. So remember what I said about the seat? It's a double-sided seat. We've picked the side that we wanted that was in there before that seemed fine, so we'll slide that back in there. Now we need the retainer, but first of all, don't forget the ball bearing. Slide the ball bearing back, but sit it up so the ball bearing sits in the seat. Now what we can do is we slide the keeper in with our anti-seize. Make sure it's nice and square. Now that you've put new O-rings on there, you'll find that, oh, hang on, I can't push that back in like I did before. What's going on? I've got something wrong. Well, you haven't. What you're trying to do is you're trying to push new O-rings back into a cylinder. So what you can do is hold that up like so, and you can give it a little tap. Now what would I use? Wow, I just used the hammer on the top of these retainers? Absolutely not. You'll bust them off. So what I suggest you do, if you don't have a drift to put in there, you can use a screwdriver. Just make sure you don't damage the threads, and start it by tapping it 3 different places. But just in behind those keepers is where I'd start it. So you'll tap that all the way home. In this case, what we'll do is we'll put it in the vise, like so. Open the vise, put it like so, and there we are. So it's all sitting up there easy for me, so I'm not trying to balance it as well as tap them home. So just small, sharp taps in behind each keeper, because that's the thickest, meatiest part of the retainer housing. And there you are. There's the second O-ring, creating a bit of torque or resistance as it goes into the cylinder. And look how easily, because I've cleaned it, it's easy to get it back home. If you don't clean it appropriately, that will cause you all sorts of grief, because it'll want to kick as you put it back into place. So the one thing I need to put back in there now is the 3 shims. The 3 shims, remember, ensure that this comes out from the pump at 6 o'clock. If I miss one shim, it'll be round at 3 o'clock. If I miss another shim, it'll be round at 9 o'clock. So we want it at 6 o'clock in relative terms. So can I use Vaseline on these? Absolutely no problems at all. We're more inclined to use some anti-seize. So as you can see, they've given us adequate anti-seize to do this job. Now just smear the anti-seize over these, like so, to ensure that you've got a good coverage on there. Why do I do that? So when it comes to reassembly, I've got some chance of getting them apart. So all of this lubrication that we've put in this pump is washed out with our first solvent rinse prior to putting paint in the machine and ensuring the machine works. So I put a new ball in there, a seat. What do I need to do to check that it's okay? I'll put some oil in there and ensure that there's nothing coming out the bottom of it. There isn't, so that means that that ball is seating correctly. So that is a good repair and good to go back on the machine. So what you can do with that oil is just run it up around the top here to assist with lubrication. A little bit of Vaseline, like so. What's left of the anti-seize, you can squeeze it out of the tube, like so, and slide that around the thread. Now that is good to go back on there. So what we can do is, we need to put this back on there and not just put that back on the pump, because it leaves this ringland exposed to damage. So what I'm inclined to do is put this foot valve back on there. You don't have to tighten it up, just put it back on there, and you know that your shims are in there, the ball cage is in there, the ball is in there, the seat is in there, and all the O-rings are in there. So as far as this pump's concerned, we've rebuilt it. You need to hold this nut and undo this valve with the valve open, because underneath this stem is a little tiny ball bearing and a tungsten carbide seat. Exactly the same as what I showed you here. It's a tungsten carbide seat and a little ball bearing. That is the same, so that's all that's in there. So if that's not working, you'll need to hold that nut and undo this, and you'll find that there's a little ball bearing in there. It's on the end of the stem of this rod. There's a tungsten carbide seat, and underneath that tungsten carbide seat is a nylon sealing ring which goes in the bottom. So if at any stage this doesn't work, remove this whole body with this undone. Now, when you reinstate this, just make sure that you have this loose, because if you tighten this up and then wind it in, you'll squash the ball into the seat and bust the seat. So you must have that open. So to ensure that we've done this properly, we know that the filter cavity is clean, we know that the cylinder cavity is clean, all our exhaust ports are clean, the threads are clean. If that doesn't work, remove it, repair it as I just mentioned. Make sure that this seal here for the taper of the connecting hose is nice and clean and concentric, and it is, so we're all happy with that. A little bit more anti-seize on this one here, like so. Probably a tad of anti-seize on this thread here to make sure that it's easy to reassemble. Now our pump is ready to be put back on the machine.